Hi, in this screencast we are going to look at the differences between ionic and molecular bonds, and I'm going to give you some ways to look at a pair of elements and decide if they are going to become an ionic bond or a covalent bond. Briefly, let's run through a couple of the characteristics that are specific to ionic or covalent. The force that holds together an ionic compound is very strong. It is an electrostatic attraction, which means that you have positive and negative, and they are trying to stick that way. As a result, you have high melting points. These compounds are very hard but brittle, meaning they'll break up into crumble. They are not electrical conductors in the solid state because the ions are neutralized, so you have as many positives as negatives, so you don't really have any free electrons. In fact, you don't have any free electrons, and the ions cannot move. In the opposite, you have, in covalent bonds, you have attraction between the two elements. They are sharing electrons, so they are much weaker and they melt at low temperatures. There are a couple of different ways that you can identify if a bond is ionic. Covalent can be two different groups. You can have covalent polar, and you can have covalent nonpolar. And you can decide these characteristics by looking at the electronegativity differences. So sometimes we will give you a chart of electronegativities, and if the differences are less than 0.3, then it is covalent nonpolar. If it is 0.3 to 1.7, it's covalent polar, and if it's larger than 1.7, then it is considered to be an ionic bond. Another way that you can identify a type of bond, ionic bonds are between a metal and a nonmetal, and then covalent are between two nonmetals. So you can't really look at it and tell right off the bat if it's polar or nonpolar for the covalents, but you can definitely tell if it's two nonmetals, then it's a covalent bond, and if it's a metal and a nonmetal, then it's ionic. So here's some sample problems to look at. You can take, for instance, if we have a bond between sulfur and hydrogen, and sulfur's electronegativity is given as 2.5 and hydrogen is given as 2.1. When you subtract them, you get an electronegativity difference of 0.4, and this is going to be covalent. And this is on the low end, so it's probably close to being nonpolar, but it may be slightly polar. All right, so we can compare sulfur and cesium. So 2.5 and 0.7, which would give us a 1.8. This one would be ionic. All right. If you did chlorine and hydrogen, you have 3 and 2.1. That would get us 0.9, and this is covalent as well. And this one is definitely polar. So as you can look back at these, you can see sulfur and hydrogen are both nonmetals, and that makes sense that they're covalent. Sulfur and cesium, sulfur is a nonmetal, cesium is a metal, so that makes sense as an ionic. And then chlorine is a nonmetal and hydrogen is a nonmetal, and that is making sense as covalent as well.